So yeah, I'm Aryan Ujjwal. I'm a rising junior at Westwood High School, one of the top high schools in Austin, Texas. That's where I'm from. Yeah, and I love programming. I know many languages. Like I'm proficient in Python, Java, HTML, JavaScript, and I'm learning C++ currently.
My name is Aditya Vijay. I'm going to be a freshman next year at Walter Payton High School, the fifth ranked high school in the country. I've experienced in many coding languages, JavaScript, Python, HTML, CSS, and now assembly after this class.
Alright, let's start. So, peripherals are one of the most important parts of a whole board over here. Both the peripheral and the CPU work hand in hand. We all know that the CPU is like the brains of any given device, and so what peripherals are is like it's like the tools of any given CPU. Where it's like the tools that enable the CPU to communicate with the external world. You could imagine the peripherals as like the hands, arms, eyes of the actual CPU, so it can interact with the external world. Some of the peripherals include you have buttons, sensors, and displays. These are examples of input-output peripherals. The main ones we'll be using in our demonstration today is VIA, which basically just takes in the inputs and outputs. We have GPIOs, which help in reading and sending off data. And also we have LCD screen, which is this, which basically just shows the return of like whatever we're doing. The goal of this whole presentation is to help you guys understand how the input and processing can, convert into a proper output. And I hope you guys enjoy it as much as we did. Alright, let's start with VIA. I mentioned how VIA was like one of the most important parts of peripherals. This is like the backbone of everything. VIA, you can imagine VIA as like a bridge, which basically connects the CPU with other peripherals and external devices. Like it connects to the buttons, the sensors, the displays, everything like that. It helps in sending inputs and also in sending interrupts, which Ali here will be explaining in the later slides. It also helps control the outputs for what is displayed on the LCD screen. And also, it translates data between the CPU and the peripheral. And this is a diagram that we created, which helps you understand how the VIA actually communicates. We first get an input, which is then sent through the VIA to the CPU. The CPU does its processing and sends it back to the VIA, which is then sent to the LCD screen. You could see the VIA as like a middleman, and you could imagine the VIA as imagine like the CPU as like a boss of a company, and the VIA as like a secretary, where the boss is giving instructions to the VIA, which then the VIA sends off to the workers or the other peripherals like buttons and LCDs.
So next we're going to talk about the GPIOs, which are input and output pins. The GPIO pins are located inside the VIA right here, and there are 16 total GPIO pins on the board. They can be assigned as either input or output dependent on the engineer's desire. So in our system we use 8 input, 8 output. Right here you can see this is part of the pinout. These are each of the GPIO pins that are in the VIA. So the default computer, the chip itself, has no GPIO pins, so that's why the VIA is essential to our system because it allows it to communicate with outside devices. Without them, the CPU can't communicate externally, so it's a very essential mix. The LCD, or the liquid crystal display, this shows our final display for our project. So what it does is connect it to the CPU via the VIA. So it's a memory mapped I/O device. You might ask what that means. A memory mapped I/O device means that the LCD retrieves instructions from memory. These instructions are assigned by the CPU in the beginning. So when the CPU receives a signal, an input, it takes in that input from the VIA, and after that it stores instructions and addressing in memory that the LCD is then able to understand and display an output. Interrupts are something else that are very important. So in the diagram that we showed earlier on the VIA, you might have seen that the VIA sends a signal to the CPU. The signal that the VIA sends to the CPU is called an interrupt. So when the CPU is running and doing its regular processes, there are 3 things the CPU is trying to do: fetch, decode, and execute. This is the regular cycle of the CPU. What an interrupt does is it interrupts this cycle and it tells the CPU, you need to do this. So when it receives an input from either like a button or something like that through the GPIO pins, the input signal, the interrupt tells the CPU that you gotta generate an output or you have to do this thing. So in our system, what happens when an interrupt is sent to the CPU is told, okay, you have to generate an output for this LCD screen. So over here you can kind of see a sequence, so button press via interrupt, and the CPU outputs to the LCD. How it all fits together. So we've talked about all of the parts and peripherals and everything. Now we're going to discuss how it all works together. So this is the sequence of how everything fits together. So first the button is pressed right here on our system, and this signal sends the signal from the button via GPIO input pin. The VIA then detects this input and sends an interrupt to the CPU, as I discussed on the previous slide. The CPU then reacts and decides what to write into memory so it can display it onto the LCD. After that, the CPU sends the output to the VIA. The VIA is able to translate the CPU instruction and let the LCD understand what it is. And then the LCD then displays the result. So now we'll discuss our demo of how everything works together properly. Right here is a computer. This is that we've used for it. So I'm going to demonstrate.
So this is work. This is like our home. This is where we send all the commands that based off of the code we wrote. And alright, so first we start off by writing this is basically it's basically just connecting this board to the computer, waiting for further instructions.
Anything you need that would be applied to your test.
But over here, I'll be out. Because over here, this is where we'll be able to see what the display is actually doing. Okay, so we start off by doing
you kind of struggle to put it all together. So you can say, let's try to nail
FAA.out. So what this does is it flashes all the code that we wrote on this computer onto this board through the wire. This is basically just telling the board, oh, I want you to do this, and this is what I want you to review. So now I'll do /R, which basically just resets to make sure that there's nothing actually that's on the program or anything stored on the memory. And then after, we'll do /, and that's basically toggling on the auto clock, and that just helps in. So there's something called clock cycles, and what clock cycles do is it's basically trying to make this board symmetric, so more ordered, where when I do a clock cycle, it'll give me a certain output. So when I'm toggling auto clock, this is basically telling it to continuously do clock cycles every time.
So let's begin. So we're going to fire
you can see this is the auto clock working, it's giving an output, and now when I click this button, this value will change by 2 bytes. And keep in mind, this value is in ASCII hexadecimal.
Discerning a reader, right? By giving it power.
Now this value changes by 2 bytes, which will turn into 0 to 0. And yeah, this is our program.
Essentially, it's just a trash can for everything.
Thank you.
And then
Thank you.
you can take